Good morning. Good morning. You're welcome to today's lecture. Today we take a look at pharmaceutical calculations. Pharmaceutical calculations, BDT 253. Then we'll go over to a new topic: ratio, proportion, and variation. Ratio, proportion, and variation. Okay, so ratio, proportion, and variation. You saw the material I sent, right? Yes, sir. I sent the variation material. So study ahead. Study ahead. If you have not gone through this material by now, you are wrong. Okay, so without wasting time, this is not the first time you've been dealing with these three terms: ratio, proportion, variation, right from your secondary school. So I don't think it's what's that on your hey, what's that? I don't think you have issues with it. So can someone tell me what do you understand by the term ratio? Ubudike, tell me what do you understand by the term ratio? Pacha, I'm talking to you. Uh, I called your name now. Oh yeah, tell us. You say what? Put it anyhow. Put it the way it's in your mind right now. We will understand. Now be the helper. You say what? Can you hear? Ratio is the proportion of this against this. What are you saying? I go Benedicta helper. Ratio. What is ratio? Huh? The what? Relation. Gift or help us. You don't know. Who knows? Nobody knows. Cynthia, yes, say it. Say it. Look at this human being. Sit down. Oh yeah, tell us what is somebody tell relationship. I say what you understand, not what you read for us. What do you understand by term ratio? Two numbers. You're comparing two numbers. You have yes, it's something like that. But I want you to smoothen it. Who is what? Mama, yeah, say it. It's a fraction of two numbers. All right. You know, there's what is called, how do I put it now? Like now, let me use what's okay. Ada and Amma now. If you bring Amma separately, if you want to talk about the skin, the complexion of Amma separately, now you can say that Amma is she fair? She's not fair, right? Is she dark? Is she dark? Is she dark? Okay, good. Ada, Amma, Ogudike. No. Chinaza. Compare their faces now. Now, Chinaza, is it dark? Is she dark? Black? Anyone can call it. Hello, one house, please. Now, see Ada now. Ada is fair, right? She's fair, right? Well, you're making noise. What's all this? I'm trying to lay foundation to what you're making. I'll go straight and just give you the vision and continue my class. What's all this? Everything you turn it into a joke. We are trying to say now, help you understand this ratio. You're making noise. I ask ratio now, you couldn't say anything. I'm trying to bring it down so you understand it. You're making noise. What do I do? What's wrong with you? Now, she's fair, right? Good. If you bring Ada separately now and say that you can absolutely she's fair, right? Now, but if you compare her with Odogwu Achona, you will put an adjective to qualify her fairness, right? Right? And Amma now, when compared with Chinaza, absolutely, Amma is dark. You can say dark or black, anyone wants to say. But relative to Chinaza, will you comfortably say that she's black or dark? In terms of who is fairer, you will say that she's what? Even though, yes, you know, absolutely she's what? That. But you're not comparing her with who? You cannot say absolutely, you cannot say so. I'm trying to point out the difference between absolute value and relative what? Value. Now, when you have a number, let me also use a number to explain this. If you have two number, if you have a number now, this is 4, right? This is what? 4. Now, then 4 and 2. Absolutely, this is 4. But if you want to now compare 4, the value, the relative value of 4 to 2 is what? If you want to now compare the relative value now, you have to do what? Am I communicating? You have a number. You have a number that is actually 2 over what? 1. Am I communicating now? Am I communicating? Now, here absolutely this is 4. But with relative to 2, this is no longer 4 now. Am I communicating? Now, ratio is simply the relative magnitude of two words quantities. You cannot just, yes, number, you can say number, but you know we are dealing with denominator what? Numbers here. We are dealing with not just a number that is abstract. We are dealing with quantities. Are we together? So with relative to 2, 4 is to 2. 4 is to 2. If you break it down, everything will now be what? The one you solve in your calculation, you say 2. This 2 is relative. Are you aware? Because you are talking about 2 over what? 1. From where you got it from? We have what? 4 is to what? 2. Am I computing? Now, why we said in our when we treated a fraction that ratio and fractions are talking about the same thing is because in fraction you also compare two quantities. Are we together? You compare two quantities because once you start saying this part of this in this, you are comparing part of a whole. There's a quantity you place on top, right? You're comparing with the whole, which is what? Also quantity, right? So at the end, you have 1 over what? 2. If you now want to put it in this form, that part, the value, the magnitude of that part relative to that whole is 1 is to what? 2. 1 in 2. 1 is to what? 2. 1 in 2. 1 is to what? 2. They're talking about what? The same thing. Out together. That's where, as I told you, that's where the term rational came from. Because rational numbers are those that can be expressed in this form. Am I completing? Can be expressed in this form. Out together. Now, if you understand this, I will now tell you now categorically the ratio of two quantities or ratio of quantities is the relative what? Magnitude. The relative what? Magnitude. The relative what? Magnitude. So ratio of quantities is their what? Relative what? Magnitude. So as I said before now, the term ratio has two terms. We have the first term and the what? Second term. First term and the what? Second. Where is the classroom? Where is your reason? Okay, so let's continue. So it has two terms, the first term and the what second term. So if using symbols or alphabets, you have, if you want to compare two quantities, quantity A, the and quantity what B, their ratio is expressed as A is to what B. A is to B. This means A is to what B. A is to B. Now, if it is A is to B, this A here is the first term. This is the what? Second what? Term. So this can be comfortably expressed as what? A over what? B. A over B. So we are not going to claim but today. When I came here, I made an important. I told you to guard these things, keep them, guide them, because you may come if you leave this place open. So people can come in here from anywhere. Other students can come in, take whatever they want to take and go their way. So how long will we be bringing up duster? Does it make sense? And I know I gave a direct instruction to your assistant class. I say hold these things, keep them, go back to the hostel, come out with them. I gave you strong, but the issue is that you are losing dedication for real. I don't know what is distracting you. I will telling you this. I don't have my own. You are losing the dedication. I just pray it ends well. All right, so gift, please, after every class, keep this thing. Huh? If there's any leftover marker, listen. If there's any leftover marker, just pack it and keep. Every morning, come out with it. All right, so I said that we have that if we have two numbers, A can be any quantity. It can be a number, it can be any quantity. So A and what? B. So if you are comparing their magnitude, so it's what? A is to what? B. A is to what? B. And I say that this is the first term, right? And this is the what? Second term. Now, this can also be expressed as what? A over what? B. So this is what ratio is all about. And all the rules that apply in common fraction also apply in what? Ratio. The same way we have equivalent ratio, equivalent fraction, we also have what? Equivalent what? Ratios. Are we together? Yes. So the same rule that apply in what? Ratio, apply in fraction, apply in what? Ratio. Good. Now, listen carefully. Listen carefully. The terms of a ratio, for it to be a ratio, the terms of the ratio must be of the same denomination. Am I communicating? Should be of the same what? Denomination. If you have something like this, you have 2 gram over 4 gram. They are the same what? Denomination. They can form a ratio. Am I communicating? So you are comparing the two weights, right? Yes. Good. So if you are comparing 2 male to 3 male, they have the same word denomination, but you have no business saying that you are getting a ratio, that this is a ratio. 4 male. It's not a ratio. That's why at the end of, this is a concentration term. Am I communicating? Yes. But it's not a ratio as per the ratio. That's why at the end of the whole thing, you will still have the answer to be 0.5 gram per what? Male. Am I communicating? But if it is a ratio of ratio, what you see is what? What you see is what? 0.5, or simply 1 is to what? 2, or half of 1 is to 2. Am I communicating? The unit will disappear. So if you are given a question that has to do with ratio, try to align them in such a way that the units will do what? Cancel what? Each other. Now, if you understand this will help us understand what is proportion. From the concept of equivalent fraction, equivalent ratio, this gives birth to what is called what? Proportion. Because a proportion is composed of 2 ratios. A proportion is composed of what? 2 ratios. And the 2 ratios must be equal, must have the same value. That means the ratio must be equivalent. Remember equivalent fraction. Equivalent ratio is talking about the same, just the same way you generate equivalent fraction by dividing the numerator and the denominator by the same number, or multiplying the numerator and the denominator by the same number. That same way, you can also generate equivalent ratio by dividing or multiplying the first term and the second term by the same what? Number. See what I'm talking about? 2:4 and 1:2 are equivalent ratios. This is the first term. Divide the first term by 2, you have 1. Divide the second term by the same 2, you have what? 2. They are equivalent to what? Ratios. Now, the same thing, 4:8. All these things are equivalent to what? Ratios. Because they have the same value. They have the same what? Value. Now, if we say that proportion expresses equality, proportion expresses equality of two ratios. If that is what we mean by proportion, what it implies is that 1/, we hope you know that, of course, you know that 1:2 is 1/2, right? So 1/2 can form is equal to what? 2/4. This is what is called what? Proportion. It expresses, once these two ratio, this first ratio, second ratio, once they have the same value, once they are equivalent, what it implies that they can form a proportion. They can form what? A proportion. So in that case, you have symbolically, you have A is to B. We have, and that this is the first ratio. C is to what? D, second ratio. Now, these two ratios, for them to form a proportion, they must be what? Equivalent. So that means A is to B, C is to what? D. Am I complicating? But this is not equal to. It's not called equal to. If you want to read it, you say A is to B as C is to D. A is to B as C is to D. Now, this can also be expressed as written this way. It can also be written this way. A is to B. This thing now, this form is now double, right? What it means that A is to B as C is to what? D. You can also leave it in common fraction form. A over B is equal to what? C over D. Here, just equal to, but it means as. In writing, it's equal to, but if you want to read it, it's what? As. A is to B as C is to D. These things is what we call what? Proportion. Now, just as we have in a ratio the first term and the second term, here in proportion we have 4 terms. We have 4 terms in what? Proportion. We have 4 terms in proportion. And the terms are, the first term, A, this is the first term, A. The first term is A. Second term is B. Third term, C. Fourth term is what? D. Am I completing? So we have, this is A is to B as C is to what? D. So first term, second term, fourth term, and what? Fourth term. So these 2 terms that form the boundary of the proportion, this one here are the outer members, or you call them the extreme. Outer members or what? Extreme. They are the outer members. Why this one, this B and C, they are the what? Or what? Hey, what I go? Tell me. I'm listening. Inner member. Uh-huh. Who say middle? Who say middle? Who say middle? Be proud of yourself. Be confident. So we have these are the outer members of the what? A string. These are the middle member of the what? Me. Outer members A string or A string. Middle member or what? Me. As MEAN. Yes. It's from this proportion that your popular cross multiplication came from. That thing you were doing, a cross multiply. This is where it came from. Once you equate two ratios, if you are looking for one term, you can find the other word. If you have three terms, you can find the one term you're looking for. Am I competing? Yeah. Provided you align them properly based on their denominations. If you align them properly based on their denomination, you can easily find the one you are looking for. Now, once your alignment is in order, it doesn't matter the position. The one you're looking for can assume this last position. The one you're looking for can assume the first position. It doesn't matter. What matters is that you align them well, so that those that are of the same denomination will be one side. Those that are of what? The same denomination will be what? One side. Once you align them properly, then you can easily, the position doesn't matter. Now, if you have, let's assume we have, this is A over B is equal to C over D. And you are given the values of A, B, C. But you don't know the value of what? D. You are looking for the value of what? D. Now, there's what is called cross products. Cross product, okay, let me make a general rule. The cross product of the cross products of the outside of the you can say the cross product of the first. Let me start with known to the unknown. Let me say the first term, okay? You can say the cross product of the first term of the first ratio, the cross product of the first term of the first ratio, and the second term of the second ratio is equal to the cross product of the first term of the second ratio is equal to. Just listen first to understand what I'm saying, okay? I say that the cross product ratio, right? Yes. And this is second ratio. I want you to understand this before we start calling the big names. Try to understand what I'm doing, so that when I start using ASIM and all those things, you will not get confused. That's why I'm taking it like this. This is the first what? Ratio, right? This is proportion, right? Yes, sir. That has two ratios. This is the first ratio, right? This is the first term of the first ratio, right? Yes, sir. Second term of the first ratio. This is the first term of the second ratio. And but in general, this is the first term of the proportion. Second term of the proportion, right? And what? Good. So now, I want to make it a general that the products. God bless you. The cross products is something. What do you mean? Okay, it's something. If you say product, it's talking about what? is something. Listen. The product of the first term of the first ratio and the second term and the second term of the second ratio is equal to, that is A times what? B is equal to the product of the what? First term of the what? Second ratio and the second term of the what? First ratio. So we have what? C times D. Is it clear now? Are we together? Okay, sorry. God bless you. Thank you. Sorry. This is A and D. Sorry. And C and what? And what? No problem. B and C. No problem. Hey. So the first term, the product of the first term of the first ratio and the second term of the second ratio is equal to the product of the what? Second term of the what? First ratio and the first term of the what? Second ratio. Now you can also put it this way. The cross product of the God bless you. The cross product of the what? First term and fourth term of the what? Ratio. Proportion. The cross product of the what? First term and the fourth term of the what? Proportion is equal to the cross product of the what? I want it together. Good. So if you want to, you can replace all those things with the extreme and the what? Mean. Anyway you put it. Once you have the basic understanding, you can put it, you can play around it, use any term to explain it. Now, this is the basis of your cross multiplication. This cross product, this equality of the cross product is the basis of your what? Cross multiplication. When you have two ratios. Now, let's assume that you are looking for B. That thing you say cross multiply and make B the subject of the formula. So you equate the cross products, then make B the subject of the formula and find their what? B. Now let me tell you, if I'm not mistaken, up to 90% of the questions or any calculation, anything you are doing in pharmacy calculation is built upon what? Ratio and proportion. This is where people start failing this course. Once you have issues with this, you will fail this course. Just understand it and be happy. Take this topic seriously. We have issues with this topic because even the topics you will be, other topics is still built on what? This informs the substance of most of the calculations you'll be doing. At the end, you must set a what? Proportion. Either you're looking for the first term, or the third term, or the fourth term. So please take this topic seriously. Even if you end up not, maybe you aren't able to cover other topics, but you know proportion variation very well. What I mean is that you're given word problem that is practical calculations. You can apply these questions and solve it well. You can apply this and solve the even if you are not able to cover other topics, you can never fail. Highest you will be playing around 50 something. It's not possible that you fail, because if you see that question, once you understand it, you can apply it and solve it, even if you have not even read that topic. That's why I want you to take this Seriously. If you go to the revision questions, the course material I sent you, you see that the questions there are questions from dosage calculation, other topics. If you go to questions behind the course material, at the back of the at end of the topic in ratio and proportion, you see that questions there are questions some of them have to do with dosage calculations, which is another topic on its own, and some are practical questions. Now, even the examples we are going to solve now is still under dosage calculation, but you want to test your knowledge of what? Ratio and proportion. Simple. So the topic forms a what? A very important what? Part of all the topics we are going to do. Are we together? Okay, so I think we have told enough stories. Let's look at some questions. Let's see what we can make out of. Put down this question from this course material. It says, if three tablets contain 975 milligrams of aspirin, if three tablets contains 975 milligrams of what? Aspirin, how many milligrams should be contained in 12 tablets? How many milligrams should be contained in what? 12 tablets. This is the normal thing you say, this is this, then this will now become that. Is not true? So before I continue, there's something I want to let you know. Please listen carefully. I just remembered it now. I don't know who the person is, but a parent called me and was talking about asking if increment of our school fees is true. I'll still call the parents to apologize because I was not happy with such question from a parents. I feel bad when a parent is doubting his or her own what? Child. I feel so bad about it. And I get angry when parents ask me such question, whether it's true. If you can't trust your child, I don't know. But at the same time, it's not completely their fault. That's the point. In fact, I was angry with the person. I even cut call. You can't trust your child. I just cut call. And I was like, what nonsense is this? But I sat down a bit and gave it a thought. I was like, it's not completely their fault. So that's why I want to speak to us. Please, let's mind our ways. Yes. Let's mind our ways. Let's mind our ways. Somebody you are dealing with should be able to trust you. If your parents don't trust you, I don't understand again. It doesn't make sense at all. I don't know. I'll still call the number and apologize, then talk to the person. But I am not happy about it. It doesn't sound well. It doesn't sound well. I don't know who the person is, but it doesn't sound well. So I said that if 3 tablets contain 9.4 milligrams of aspirin, how many milligrams should be contained in 12 tablets? Good. There are how many? First of all, if you have a question like this, ask yourself, how many denominations are there? Two, right? Two denominations, right? Good. What are they? Good. Tablets and what? Telegram. Now, let's start with tablet. Tablet, how many times were we given in tablets? Only two times in tablets. And that two times will form a ratio, right? Right? Good. And they should be aligned, right? Now, milligram. How many times were we given? So we're giving only one time a milligram. So we're looking for the other what? Time. So we can also align it and set a proportion with it and find our what? Our answer. So if you decide, you can align first. You can align the milligram first. If you decide, you can align tablet first. Doesn't matter. What matters is that the alignment is in order. So your tablet can come first. Tablet can come. The ratio that involves tablet can come at the first ratio. It doesn't matter. What is it called? Milligram can come at the first ratio. It doesn't matter. So now I may decide to start with what? Tablet. So I have, what are the tablets there? Huh? Three what? Over what? 12, right? Is equal to what? Is to what? Huh? 9 what? Is to what? We don't know. We call it what? X. So we find that we have established here that this product is equal to this product. So we placed again. We have that 3 tablets times X is equal to what? 12 tablets times what? So we make X the subject of the formula. So this is what? 3 over what? I'm breaking this thing down. I know why I'm doing this. Because I'm doing it for you, know yourself. Better grab it now. If you don't understand, ask me question. Don't keep quiet. Ask.
If we do 3 into 12, yeah, then we plus the 900 among it.
You plus?
Yeah.
How? I don't understand.
3 tablets plus 900. Then into 3 into 4 is 12. Then we'll break that number. So 10 to 4.
I'm trying to understand your question.
3 tablets.
Hello. She said, so what?
3 tablets, and 3 into 4 is plus tablets. Then write that 905 into 4, then plus it.
Plus it. See, hello, see. There are different way around these things. I'm just following. There's something I'm doing here. I'm trying to solve this with respect to the topic we are. There are many ways you can do this thing, okay? So here, what I'm going to do here, so tab will do what here? 3 divided 12 is what? 4 times 975 is what? What? 3,900 what? Milligram. Is it clear? Is it clear?
Yes.
Cynthia, you're doing your face as if it's not clear. Are you sure? 3,900 what? Milligram. Let me write where we started from. We have A over what is equal to what? C over D, right? Good. Now, if we decide to place the first ratio, the milligram to come first, we still have the same what? Results. Am I completing? If we decide to put it this way, 975 milligram over what? X is equal to what? 3 tablets over what? 12 tablets. We have the same what? Answer. But if you mistakenly If you are clever, go and start telling me. Let's see whether it works, huh? 3 tablets over 975. Anyway, that's how you can put this thing, oh, but that one is technical. That's how you can do it and get the same answer. Yes, that's how I can align it. But why I don't want to go through that message, some people may not be able to do it and they may end up having issues. That's how you align it, you still get the same answer. But in that case, you are not actually doing a ratio now. You are just manipulating the whole thing, but you still get the same answer. I will explain. Watch out. Let's do this one first. 3 tablets over 975 milligram. Okay, so let me say 12 tablets. Sorry, three tablets over 975 milligram is equal to 12 what over what x. Let me write out another one. I want to bring out some things that may happen on the course of your solving question like this, so that you be careful about what you are doing. Let's look at this one. 975 milligram over 12 tablets is equal to 3 tablets over s. Look up. This is the rule, right? The first ratio, the one you call ratio, this ratio should actually be a ratio. In the sense that they should have the same units. Now, that's how you can go around without following this and still get your what result. What you do is this: you look for the one that belong to each other. Look for the one that belong to each other. Put them together. The one that belong to each other. Put them what together. Look at this now. From the question, 3 tablets contains how many milligram? 975. So they belong to each other, right?
Yes.
Good. You can actually do what? This over this, right? 975. Good. Even though we are not actually doing, because this cannot cancel this. Okay? You only have tablet per milligram if you want to break it down. But you intentionally go around it by putting them together, okay? Then the 12 tablets belongs to the milligram you are looking for, right? You can do 12 tablets over what? X. And make X the subject of the formula. You get the same answer. True of us? Good. Why I don't like starting from this is because some people will go and commit this offense. They'll get confused. That's why I like people to follow this. Even in exam condition. Even in exam condition, you see yourself solving this.
That's what you said. That's popular.
You say what? What's that? I'm trying to explain something here. This one is correct because you intentionally align it well, even though this is not a ratio. I'm not complete, but you know the which I said that 3 tablet 975 milligram belong to what 3 tablet. You put them together. These belong to the one you're looking for belong to 12 tablets. You put them together, right? You can make S the sort of formula and get your answer. But why I was trying to explain that why I like starting from this is that some people will end up solving it like this. I've seen it. It's not me. I've seen it. I've taught this course for how many years now in this school? Since 2020. So I see it every year. I'll just laugh. I see it every year. They will end up solving it like this. They will align this one like this and carry they confuse where to put tablet, where to put milligram. They get confused because this is what they learned it with. Out together. That's why I want you to go like this. Once the unit are not the same thing, stop. Be sure that the unit are the same thing. It takes higher level of reasoning before you can solve this. Because some will end up carrying this one and putting here. Mixed up everything. So this thing is wrong. Am I communicating? So you know where you belong and know the one you want to use. Even the intelligent ones have failed it several times because of mixing up things. So calm down and be humble. I know the one here that will help you to get your mark. But whatever you do this way, you still get the same what answer. So this one is wrong because at the end, it's mixed up. You cannot have tablet squared. Then maybe at the end you'll be getting tablet squared over milligram. What are you solving? Tablet squared over milligram. Which quantity is that one? So that's why I have big question mark on this one. So please be careful about it. Now, this question can be twisted. You can generate up to 3 questions from this quick question because you can generate 4 questions or 4. The first one you can look for the first step. Second one you can look for the other one. Which anyone that they're looking for, you can actually make it the subject of the formula and get your what answer. Ask. Yeah. What did the question say? Listen. How many words are where? Yes, now 3,900 milligram of aspirin will be contained in 12 tablets. Full stop. That's the answer. Is it clear? So let's see. All these. Okay, let me solve one more question before I enter under. You have up to how many questions behind? You have up to 22 questions. All these things we are seeing here are nothing but dosage calculation, which where you employ what? Where we employ what? Ratio and what? Proportion. Now look at this question. Let's look at question number 1. It says if an insulin injection contains 100 units of insulin. If an insulin injection contains 100 units of insulin in each milliliter. If an insulin injection contains 100 units of what? Insulin in each milliliter. Ml. How many milliliters should be injected to receive 40 units of insulin? How many milliliters should be injected to receive 40 units of insulin? If an insulin injection contains 100 units of insulin in each milliliter, how many milliliters of insulin how many milliliters should be injected to receive 40 units of what? Insulin. Look at that question. How many denominations are there? What are they? Unit and what? Good. So let's start with units. How many terms we are given in units? 2 units, 2 terms, right?
Yes.
So we can align them like this, right? We can align them, right? 2, right? What are they?
100 units and 40 units.
100 units is to what?
40 units.
As
1 milliliter.
Is to what?
Yes.
Is to what?
Yes.
Is to X. 100 units contains what?
1 mil.
In 1 mil, right?
Yeah.
So 14 units will be contained in what? We don't know. So this is not certain as saying 100 units over what?
40 units.
Remember I told you to be, please carry your along, please, to avoid issues. 1 mil over what? X. So we make X the subject of the formula. We cross multiply. So X is equal to what?
40 units times 1 mil over 100 units.
Times what?
1
Over what?
100 units.
100 what? Units. Unit cancel what? Units. 40 divided by 100 is what?
0.4.
0.4 what? Mil. So if 1 mil delivers 100 units, that means 0.4 mils will deliver what?
40 units.
The dosage form is what? The dosage form is what? The dosage form is what? What liquid now? Injection, right? The active ingredient is what? Insulin, right?
Yeah.
So 1 mil. So if 1 mil of the medicine, right? The dosage form is medicine, right?
Yes.
So if 1 mil of the medicine, listen carefully, if 1 mil of the medicine delivers 100 units of what? Insulin, right? So 0.4 mil will deliver what?
40 units.
So if you have the insulin injection, the dosage form, and the patient needs to be, maybe it was prescribed that the patient should be injected 40 units, should be administered 40 units, and the whole thing is what? 100 units in 1 mil. Simply do what? Withdraw what? 0.4 mil and do what? Administer through what route? Intravenous. Subcutaneous. See, hello, there's something that I want to understand. Listen carefully. This whole thing is everything we are doing is just together. It's just that we break it down so you can do it well and understand this. So there's a way you link up all those things. From Pharmaceutical now we entered what? AUM. It's so disease. It's pharmacy. But we break it down into different courses so you can understand it and be able to assimilate it, study it well. That's why we have different courses. But they are the same thing. They're talking about the same thing. Are we together?
Yes, sir.
Please, let's understand that. That means as you are studying a drug, try to link what you learned in other courses about that drug or medicine or whatever. Try to link up. You'll be able to understand it better. Okay, so one house, please. One house, please. One house. I want you to solve this question. In our next class, we discuss dimensional analysis. Okay? In our next class, we discuss dimensional analysis. It's also a way, it's a shorter, more straightforward way of solving questions with what? Ratio and proportion, which is it's just straightforward. But it's somehow technical. If you don't have a good understanding of it, you have issues. That's why I want to start it as a new day when you are still fresh in a new as the first thing to discuss when you are still fresh. Now, if I go into it now, some people may not understand what I'm talking about. That's why I want to leave it in our next class. I'll start from there. So, but we'll solve a question using our traditional way of setting up proportion first. Let's just solve one question. You solve this question now. Gift, come and write this on the board, on the board fast. Number 19. Write it on the board. Then I'll give time for people to solve. Let me see who get the answer first. Number 19. Click board. Number 19. All right, look at the question. The question says if an ophthalmic solution contains 1 milligram of dexamethasone phosphate in each milliliter of solution, how many milligrams of dexamethasone phosphate would be contained in 2 drops if the eyedropper used delivered 20 drops per milliliter? You have 2 minutes to solve this question. 2 minutes. Yes. Anybody that gets the answer? The time is 9:04. Start solving. Two minutes. Look for one word. Wait now, zero for one word. Milliliter. Wait now. Milligram. Who else? Who else? Okay, you another. Same thing. Who else? Who else? All right, the time is up. 0.01. Cynthia. Okay now. No, the time is up. The time is up already. I give time now. Now let's look at the question. Let's look at the question. Let's see who. Because I said, listen again. Because I said, if an ophthalmic solution contains 1 milligram of dexamethasone phosphate in each milliliter of solution, how many milligrams of dexamethasone phosphate will be contained in 2 drops if the eyedropper you deliver 20 drops per? Please, before you solve a question, try to learn how to separate long stories from the points. Okay, it's very important, and know where to start. Sometimes where you start may be at the end of the question. Try to understand this. If you One, if you come here and start solving from here, you will get stopped. Come down here, solve from back, go up and get your answer straight without wasting time. You've been told that there are 20 drops. 2 drops should be in how many ml? You put it here again, form under proportion here and get your answer. So let's set the first proportion. Here you will set 2 proportions. Listen, there are some questions you will see. You will set up to 3 proportions. So you set up to, in fact, that's how the question will configure. So you will set up to 4 proportions. 4. You can set up to 4 proportions in attempt to solve a question. But here now you set two proportions, I think so. 2. That's why sometimes you can use dimensional analysis. In dimensional analysis, you don't preset more proportion. Like you can just in a straight line, you get your answer. So when we do that, you understand that. Now let's solve this question. Let's set look at the first proportion here. If you set the first proportion, if you want to solve it from here, you get stuck. You get stuck. So look for where a proportion that can give you 3 terms. Here now we have there's a proportion that you can form here. There are 3 terms here. Drops, milliliter, then another milliliter you are looking for. You can set that proportion here. So here we have the proportion here. Now we have 20 drops. Is to what? As what? As for what? As what? Is to what? 20 drops. I'm bringing down for our brethren. Is equal to what? Over what? X. Are we together? So make X the subject of the formula. X is now what? 2 what? Drops times what? Over what? 20 drops. Drops cancel drops. Is what? 0.1 mil. So from here now, the 2 drops will be contained in 0.1 mil. All together. When they were given 2 minutes to solve, they couldn't solve it. And that's it talking. Yeah, what? 0.1 mil. Now, we now use what we have here to come up here to set another proportion. If you come here now, you've been told here that 1 milligram of this is contained in 1 mil. All together. Now, 1 milligram is contained in what? 1 mil. So, how many milligrams will be contained in what? 2. I'm coming. 1 milligram will be contained in what? 1 mil. How many milligrams will contain in what? 2 drops. But we already discovered what that 2 drops will be in what? Will be contained. How many mil that will contain these 2 drops? 2 of us. So if 1 milligram is contained in 1 mil, we don't know how many milligrams that will contain in 2 drops, but we know that 2 drops will contain in 1 mil. So that means we now replace this 2 drops with that what? 0.1 mil. So we now use it to set what? Proportion. So if you set the second proportion, we have that 1 milligram is to what? X. We don't know it. We don't know it, right? How you know? Are you aware? As what? As what? As 1 mil is what? God bless you, 0.1 mil. Chetanna. So 1 milligram over X is equal to what? 1 mil over what? 0.1 mil. We make X the subject of the formula. X is now equal to what? 1 milligram times 0.1 mil over what? 1 mil. Mil we cancel. 1 milligram times 0.1 is equal to what? Milligram. The answer is what? 0.1 milligram. Where did they get 100 milligram from? It's okay. You exploit other. It's okay. Or when we enter density now, you start looking at that in the density. It's wrong now. It's wrong. The answer is what? 0.1 milligram. It's only one person. One person that got it. I don't wanna give for supporters club. I don't want to give for supporters club. Thank God I didn't announce any gift. I would have paid for my news. I mean, like, don't worry. If you want to do it again, I will regret it. I would regret it too. I know regret this situation well. So how many people got 0.1? Look at this one. Don't worry, we have more questions to solve. By that time, do you know why I like taking the first person? Do you know why? Someone can just sit down and say, I support the person. Call yourself and answer. That is this. So how will you know whether if the person actually solved it? Okay, what person solved? Okay, next time I'll take what you solved next time. But before I solve it, you shall calculate what you solved. Is it okay like that? Good. We have a lot of prizes to give. Don't worry. Thank you for suggesting it now. If I give you time, once the time elapses, if you are able to submit your answer before the time elapses, even if you are 20, before I start solving it, you show me your work. Where you got that answer. If I'm satisfied, then I will solve it. At the end, I will share. Even if it's all the members of the class, I will share. I will give them everything. I will give them something. Please study, okay? Yes, sir. Study. I think let's stop here. We've tried for today.
Thank you, sir.
All right. Any question? Ask. Okay, yeah. What do you guys okay? Okay. Let me share now. Got here. Oh. All right. Thank you very much for your attention. God bless you.